Guys, let's go through those steps. All right, I told you on Monday, I think I got you guys started by saying that in that first bit of information, right, this section here, they didn't give you sign equal to a fraction like they did in the first example. So you actually first had to do that yourself. You had to take the plus 3 over and it became -3, and then you had to divide by 7. All right, so then you would see that sign is negative. Sign is negative in quadrants 3 and 4. They're also telling you that theta, this angle, has to be between 90 and 270. Now, guys, this is 90. All right, that's 180 and that's 270. Does it make sense that if the angle has to be between 90 and 270, it's either going to be in quadrant 2 or 3? Right, because those are the two quadrants where you will have angles between 90 and 270. Now, if we're looking at 3 and 4 and 2 and 3, do we notice that quadrant 3 satisfies both of those conditions? All right, so that's why I underlined quadrant 3. So that is where your triangle is. Please draw that triangle down or copy that triangle down if you didn't get that. You're going to practice more of these now on your own. So it's fine if you didn't get this first one. Are there any questions on just getting that it's in quadrant 3? That first step. Now, guys, once you have your triangle, you need to remember that sine is opposite over hypotenuse. All right, so the opposite side, the length of the opposite side is going to be 3, and the length of the hypotenuse is going to be 7. But guys, because we have our triangle in the third quadrant, this length, do we notice that it's going into the negative x-axis? All right, so if we had to plot this point here, it will actually have, sorry, I was showing there, I meant here, it's going into the it's going into the negative y-axis. I said x, I meant y, sorry. This line, this side of the triangle is in the negative y-axis, all right, or across from the negative y-axis. So if we were to plot this point, that would have a y value of -3. Right, does that make sense? Because we're going from 0, if it's going all the way down to there, and it has a length of 3 units, that coordinate will be -3. All right, because from 0, if you go 3 into the negatives, you will get to -3. So that is why this side, you have to write as -3. The length is 3, all right, but the actual value in your trig ratios will have to be -3. Right, that's similar to what we did in the example, but in the example, that's the one that we calculated. We calculated the y value, and we then saw that it was negative. Guys, another thing that you need to remember is that the hypotenuse is always positive. Just write that in somewhere. Okay, the hypotenuse is always positive. They sometimes refer to the hypotenuse as the radius. So if you were drawing a circle all around with that line as the radius, it would just be positive regardless of where that line is. So it's always the other two sides, the ones that are not the hypotenuse that could possibly be negative. Right, but the hypotenuse always has to be positive. Now, once you filled in your -3 and your 7, you're going to use Pythagoras to get the other value. I just called it x in this case because it is along the x-axis. Do we see that? But guys, you could call it anything. All right, you don't have to write x squared. You can make an a or whatever letter you can use there. It doesn't matter. Now here, I just used 7 squared minus 3 squared because I was just working with the lengths of the sides. Right, does that make sense to you guys? But even if you wanted to use -3 in your calculation, you could have done that. You could have said x squared is 7 squared, that's the hypotenuse squared, minus the other side squared. Now, if you wanted to leave that as -3, that would have been fine because what is -3 squared? Also just 9. All right. So whether you use 3 squared or -3 squared, it doesn't matter. It's up to you. You get the same answer. All right. I usually just use 3 because I'm working with the actual lengths, but it doesn't matter. Okay, you can use -3 there. Then for x, if you take the square over, it becomes plus or minus square root. Now guys, because it says without using a calculator, I thought maybe you would have left it as the square root of 40, which is fine. Remember from the beginning of the year, I taught you guys how to, what's the word? Reduce it. All right, so if it's something like the square root of 40, you should actually be able to reduce it to that without using a calculator. Okay, but again, we're not really going to check. It's fine if you use your calculator for this, for the actual pi part. We don't mind that. How would you reduce this again? Can anyone remember? You would take out a number that has a square root, or you would rewrite 40, sorry, as the product of two numbers, one that has a square root, right? So you would do this, plus or minus the square root of 4 times 10. Right, and what is the square root of 4? 2. And then 10 doesn't have a square root, so that's why it's staying in there. Now guys, here we now need to figure out, is this going to be positive or negative? All right, so we look at which quadrant it's in. Does it make sense that this has to be a negative x value? Because we are on the negative side of the x-axis. All right, so the other day when we did this example, look at this first one. This is the one we did together. This one had a positive x value because it is on the positive side of the x-axis. All right, our y value was negative because it's on the negative side of the y-axis. All right, that's what you look for. Here, our y value again is negative because we are on the negative side of the y-axis, but now our x value also has to be negative. All right, so there you have to specify that x will be the negative one. But guys, it's fine if you just say from here you have x squared equals 40, therefore x equals -√40. All right, you didn't have to write all of this stuff here. That's just a bit of an explanation. So you can just go straight from x squared equals 40 to x equals -√40 or 2√10. Okay, you don't have to write that explanation down. And this question was asking for cos theta. So now remember, what is cos? Adjacent over hypotenuse. So whatever you got there, -√40 or -2√10, either one is fine, over 7. Okay, are there any questions on this one, guys? You're going to practice some of these now, 5 of them on your own for tomorrow. So it is exercise 3. Yeah. Sine is opposite over hypotenuse.
Wait. Oh yeah, so equal the adjacent side. So
No.
I don't know.
So sine is -3, the opposite side, over 7, the hypotenuse.
Yeah,
So you have to remember that sine is O over H. Then you use those two sides in your triangle and Pythagoras to get the third one. But now they've actually asked you for cos, which is adjacent over hypotenuse. Okay, which is why I use that one there. So they gave you sine, but they're asking for cos.
Cos be the adjacent side.
Over the hypotenuse. Okay, we are doing exercise 3. On page 141, you are doing numbers 1 to 5, please. Okay, do those, please keep going. You have 20 minutes. It's a lot, guys. You have to do a triangle for each of those questions, so you better get started now. Oh, sorry. Apparently there is no solution to number 5. I see here. So we're not doing 5. Let's do 6 instead of 5. So it's 1 to 4 and then 6. Guys, I just want to warn you about number 6. They are giving you information about, they're telling you that cos x is something and tan y is something. So for number 6, you're actually going to have to draw 2 separate triangles. One where your angle is x and one where your angle is y. All right, so if they're giving you information about 2 different angles, you're going to have to draw 2 different triangles. So that is for number 6. Draw 2 triangles. Okay, get going. You can listen to music if you want.